Okay, so this is a video I'm putting together that basically is going through the lesson that I'm giving to the kids that is aimed towards math interventionists or support people, anybody who's working with the kids on this material is kind of like maybe a little foggy on some of what we're doing. And so I will be going kind of quickly through some of this stuff. If you need more of a breakdown of it, just talk to me and we'll get you added to the Google Classroom that I share out with the kids, and then you can actually see the videos that I make for them. All right, but this is specifically geared to go at a much faster pace. So when we talk about multiplying with exponents and the properties of that, so the big thing is just making sure the kids understand what powers are, like why exponents, what's the point. And then there's these three things we do. There's product of powers, power of a power, and then power of a product. All right, and it's really easy to kind of confuse power of a product and product of powers, but you'll see in a second what the difference is. So the first thing is just understanding that when you're writing an exponent, you have your base, which is the number that you're multiplying repeatedly, and then the exponent tells you how many times. So if you've got 3 to the 4th here, you're saying, okay, you're taking 3 and you're multiplying it by itself 4 times. Right, so you can think about anything. If you've got 7 to the 3rd power, that would just be 7 times 7 times 7, and then you would get 49 times 7. Figure out what is it. I think it's 243. All right, so or is it 343? I don't know. Whatever. It's something, right? 343. All right, but so that's kind of the overarching idea of how that works. Okay, so the problems that the kids have to evaluate are these. So this one right here, 5 to the 4th, is just basically 5 times 5 times 5 times 5. Just teach them how to do that, and I think it's easy if you get it into numbers that make a little more sense to them, right? 25 times 25, 625. Absolutely let them use a calculator. 2 to the 5th is just 2 times itself 5 times, right? So you get 4, 8, 16, 32. All right? And then -3 cubed. The big thing is just remembering that you're actually multiplying the negative along with it if it's inside the parentheses like that. So this is different from this, right? It's a different kind of thing. So this is saying that you're actually multiplying the number -3 3 times. And the thing I teach the kids is if you're multiplying a negative by itself, if you're doing it an odd number of times, it's always going to be a negative answer. And if you do it an even number of times, it's positive, because for every 2 negatives you have, they cancel. So when you do this, you get -3 times -3 is +9 times -3, which gives you -27. If you see any, I'm kind of flying through this, so if you see any mistakes in this, just let me know and tell me to get my act together. All right, now the first thing is this product of powers. So this is where you can multiply 2 things that have the same base and basically figure out what the new exponent is just by virtue of adding them. And the reason this works is because if let's say you have 2 to the 3rd times 2 to the 5th, right? Well, if you expanded it out, right, this would be how you would write 2 to the 3rd power, right? And then 2 to the 5th power would be basically the same thing, just with 2 more 2's, right? But then if you rewrite it back in its form, well, there's now 8 2's. So you can get there much quicker just by saying, okay, add 3 and 5, keep the base the same, and you get 2 to the 8th power. All right, so this works with variables as well. So b to the 3rd times b to the 5th is just going to be b to the 8th, because you have 3 b's here, 5 here. You're multiplying them all together to make one big happy b party. You got 4 g's, 6 g's here, so it's g to the 10th. You just add them up. Now, when you do monomials, right, or products basically of this, then what you do is you just do the like things together. So I'm going to multiply my numbers together, because you still multiply numbers. And the reason this is if you have like this, if you write this out and then just kind of rearrange it, just go 6 times 2 and then get your ends by each other, you can see that, well, you're not adding them like you are the exponents, right? You're still multiplying them. So you multiply your numbers together. So 6 times 2 is 12. and then n to the 10th, because 3 plus 7. And then this one would just be 3, p to the 4th power. Big thing is reminding them that if it doesn't have an exponent, that it's 1. And then t to the 7th power. All right. Power of a power is very confusing for a lot of kids, because they're, especially after showing them what we just did, because making that transition is tricky. All right, so that's like when you have something like this, if you have 2 to the 3rd to the 2nd power. So what this is saying is, hey, I'm acting as an exponent, but instead of just on one thing, it's a thing with an exponent. So it's basically, it's 2 to the 3rd times 2 to the 3rd. So you have this, 2 times, which is, notated by that. So the same rules apply. You would add them together and get 2 to the 6th. A much more direct way, though, to get to that is you just take that, when they're nested like this, is you just take this and you just multiply it by the 3. And then you get 2 to the 6th power, and you can just go directly there. And this works for larger terms, too. Like, so let's say that, and I think, I'm not sure if I cover this. Oh, I don't. I'll save it for the next one. All right. So we have the why does this property work, and we show them that, and we show them an example, kind of similar to what I showed you. So that's why it works. So when you do these, basically you just multiply your exponents together. So this one's going to be g to the 42nd, because it's basically g to the 6th, 7 times, which is a lot to write out. But I think once you see it once or twice, you're like, oh, that was a lot of work. I get it. Right, and my g's slowly start to look like 8s. So g to the 42nd power, this would be b to the 15th. And then this one, I would do this part first, right? Deal with the exponent, so that's going to give me x to the 10th. And then times just x to the 3rd. So the 5 only acts on this one. And then once you have this, you just use, if you're multiplying 2 things together, you add the exponents if the bases are the same. So you get x to the 13th total. All right. And now the last thing is power of a product. So we're taking what we just did, but we're applying it to more complicated terms. So this is a good example of it, right? This is what this is saying is if you have this, its expanded form is this, and then you move things around and get them together. So the fast way to think about doing this is if you have tw to the 3rd, is that you're actually distributing this exponent to both of the things and multiplying it by whatever the exponent is. And if it doesn't have an exponent, it's 1, right? We don't ever put 1 there. So this would basically be t to the 1 times 3 and w to the 1 times 3, which is how you get t to the 3rd, w to the 3rd, right, in a much more fast way. And the big thing is just understanding that the exponent applies to any of the individual terms that are in the parentheses, all right? And so now, like this one, we're going to apply this 5 to the j and to the k. So that's going to give me j to the 5th, k to the 5th. We're going to do the same thing here. We apply the 5 to that. So that's going to give me x to the 10th, right? And then I apply the 5 to this, multiply it by that, and you get y to the 20th. And over here, you're going to have, and I'm going to do this in 2 steps. You're going to have negative 3 to the 3rd power, and then a, remember its exponent is 1. 1 times 3 is 3. And then b to the 4th to the 3rd power would be b to the 12th, because 4 times 3 is 12. And so now we want them to always evaluate any just straight up numbers being raised. So they'd have to do the negative 3 times negative 3 times negative 3, which, if you remember, we already did, right? Which is negative 27, and then just tack this stuff on the end, and voila, you have successfully gone through the Reader's Digest version of Unit 1, Lesson 1 with the kids, and we did it in under 10 minutes. So I hope this helps. Any questions, obviously, just find one of us and just ask. So, yeah, there you go. Bye.